Hi everyone, Mr. Allen here. Just wanted to run through a quick concept here for the power rule. It seems like there's maybe a bit of confusion and just sort of look at a couple of practice questions and hopefully clear that up. So the first thing to understand is at this point you're just starting out with derivatives. We have many more sections to follow. The only thing that you know how to take the derivative of in this first section is something that looks like this, x to the n, or really more precisely, x to the n with a potentially with a constant in front. If you have anything other than this, you have work to do. So as I look through these questions, just right off the top, this is already in the form x to the n, so no problem. So is this. Kind of missed with my circle there. So are all of these. And so is this. So 7 is actually 7 times x to the 0. We also understand, hopefully, that the slope of a line like y equals 7 is 0. And so there's a reason why we say the derivative is 0 or the slope is 0. It's because that part of the graph, this part of the graph, this part of the graph does give us a slope of 0. So all of those are fine. Where we run into trouble is if we have something other than x to the n right from the start, and then we just have to kind of get our questions into that form. If I look at something like this question, you can see that I'm not quite in the form I'm looking for. I don't have exactly a constant times x to the n, but certainly this can be rewritten as 9x squared, just basically simplifying the exponent, and then I've got what I'm looking for. Similarly, this little bit of work to it, we end up with x to the 4th over 16, or 1/16 x to the 4th, whichever you're more comfortable with. So those ones shouldn't be too bad. As long as we do a little bit of work with them beforehand, we get them in the form we want, and we're ready to go. If we have something that's a little different, like these ones, d with a root sign, h over here with a cube root, same sort of idea, get it in the form you want to start. And so we can rewrite x to the rewrite the square root as x to the 1/2, and then we have exactly what we're looking for, x with an exponent, and we can take the derivative of that fairly straightforward at that point. So f prime, the exponent 1/2 multiplies out front, subtract 1 from the exponent, I end up with negative 1/2, and then a little bit of simplification gets us to the printed answer. I'd be relatively happy with either of these last two. Probably shouldn't leave it with a negative exponent, but at this moment in time, it's really not that big a deal because we should be concentrating on doing the new work and not so much the algebraic manipulation, although that does come into play a lot in the coming sections. So again, here basically just kind of reviewing your exponent rules from grade 9 and or grade 11. I think probably grade 11 is when you get the fractional exponents in. But things like negative, well, over here I guess we had a negative exponent. I say over here, but you can't tell. What I'm saying is over here we had a negative exponent. The derivative is fine with it, but you want to recognize that the negative exponent does mean essentially x is in the denominator here. And then similarly for this one, if I can actually grab it, rewrite it as x to the 3rd, and then the derivative will be fairly straightforward because I have the form I understand. X to the n is all I know how to work with, and so once I have that, I can start doing the derivative. The 1/3 is multiplied out front, subtract 1/3. Sorry, I wrote that backwards both times. Wow. So I wrote those backwards both times. This should say 1/2 minus 1, and this should say 1/3 minus 1. The calculation on the next line is correct. I knew where I was going, but I kind of filled in this line afterwards. My apologies. I'll fix that in the video edit. And so once we've got our exponent as now negative 2/3, again, rearrange it a little bit, and simplify. So my intent was to keep this fairly short. I'm just going to pop in here and quickly mention a couple of these ones. Most of these again look fine. This is similar to the comment earlier. Just deal with the exponent, get it into a single term. Something like G here. Again, a little bit of manipulation ahead of time will get us to something we can work with. So the multiplication is the problem here. So let's just do the multiplication. T squared times t squared is t to the fourth. T squared times negative 2t is negative 2t cubed. Over here, similarly, the division is the issue. So rewrite this in terms of two fractions now. T to the fifth over the 2t minus the 3t squared over the 2t. And then we can simplify each of those into single terms of the form we want. So t to the fifth divided by t is t to the fourth. T squared divided by t is just t. And if we prefer, we can rewrite that as 1/2 t to the fourth minus 3/2 t. You've got t to the fourth now, your t to the exponent. You've got t here, and that can be worked with fairly nicely. And in this last question, I don't think there was really too much to comment on. Most of these are similar to things we've just seen. We have here an exponent in the denominator, so that specifically can be rewritten as 2x to the negative 2. Similarly, this would be 6x to the negative 3 here. And then we're ready to go. The decimals are fine. I'm simply going to be subtracting 1 from each of them, so that won't be an issue. The only sort of slightly new thing is this one, but again, based on what we just saw, split this into two fractions, 1 over x and plus root x over x. Simplify each of them, rewrite this one as x to the negative 1, simplify this, it'll be x to the, negative 1/2, I guess, and then you can work with those at that point. Okay, so I'm going to stop the video there. If you have specific questions, jump online, ask them at that point, but hopefully that clears up the basic misunderstanding, which was that you can't work with anything that is not already in this form, and so rewrite each and every term in this form to start, and then try to do the work that you know how to do.